Welcome to LabMinutes.com. In this video, we will look at how to configure quality of service or QoS on Cisco Nexus 1000V. And some of the features we will be looking at are QoS Marking, Queuing, and Policing. So QoS on Nexus 1000V follows the same MQC syntax, so if you're already familiar with the class map, policy map, and this should be nothing new to you. Just like QoS on other platforms, there are always variations on supported features, so make sure to consult Cisco documents so you're aware of what features are supported or not supported by the Nexus 1000V. Here's our lab setup. So we have two Windows 2008 server at the IP of 40 and 42 running on VLAN 32. We will be using RDP as a test application, so one server will be acting as an RDP server and the other side will be an RDP client. We also have a Win7 non-core machine that's going to be running Wireshark to sniff out the packet so we can do some packet analysis here. Now as far as the QoS configuration, we will be doing QoS marking at the host port or the host port profile. So we'll be configuring the marking to look for RDP and mark it to AF21. Then we'll be configuring QoS Policing on the uplink port channels to limit the bandwidth to 800 kbps. To anything that violates that, we're trying to mark it down from AF21 down to AF11, or we can just try to drop it as well. As far as the queuing, we will be configuring some guarantee bandwidth for the Nexus control traffic, as well as some of the VMware application traffic. And here we intentionally put our RDP client and server on two different ESXi hosts, so we can kind of force the traffic between the two machines through our uplinks so we can capture that on our packet capture. So to get things prepared, we're going to start off with configuring monitor sessions in our Nexus 1000V, so for our Wireshark machine to start seeing traffic. So here on the Nexus 1000V command line, first we need to find out which virtual interface the Wireshark machine is located. So you can do show interface virtual, and we know the name contained non-core. So you can see here is VE15, and we are going to be capturing packet on both of the uplink ports. And for us, those are port channel 1 and 2. So configured monitor session 1 with source interface. You can do port channel 1 and port channel 2. And then for the destination, we'll send it to V Ethernet 15. And since it's a trunk port, it's actually currently carrying all the VLANs that we have on the ESXi, which might be too much information for us to look at. All we are concerned about is traffic on VLAN 32, so you can put a filter and set VLAN 32. So that's the only traffic, or the VLAN traffic that we're going to see. Then we no shut, and then we make sure we do show monitor and make sure the session is up. Okay, so now going on to the Wireshark machine, we can start launching the Wireshark. Go ahead and start. And we already have an RDP session up and running. This is from the client to the server. The server is .32. And as soon as you start moving it around, you can see there's RDP traffic. So we can stop for a minute here. And we could even try this would be the file that we use to test the download. It's about 5 meg. So if you're trying to, let me get this Wireshark back up and running, and then just drag and drop. So we're basically pushing the file up. You can see it's pretty quickly. I'll download it pretty quickly. Now if you look at just pick one of these packet to look at, and you can see right now, right here, destination port 3389, which is the RDP port, and on the IP header, the DSCP value is currently set to 0, which is the default. Okay, so now we have that prep. We can start our QoS configuration on the switch. The first thing I want to do is to enable QoS stats so we can see some statistic when we do some show commands. So QoS statistic. And then first we're going to do QoS marking, which is this part right here where we do it at the ingress or input of the port. We need to specify or come up with an access list to match our RDP traffic. So we create an access list called IP access list RDP. And then we do a simple permit TCP any, and then we can match just the destination TCP port. And at the same time, if you want the bidirectional traffic to be matched, then we also want to do it at the source port as well. Okay. Now we're going to create a class map that will match the RDP traffic. So here with class map, you have to specify types. On the Nexus 1000V, there are two types, QoS and Queuing. For marking, it's fall under type QoS. And then you have to do match, always do match any, because it's most of the time that's what you want. And then we'll call it RDP. Or actually, let's call it something like app for application. Then we'll do match. And there's a number of options that you can do for matching, whether it's a cost value, DSCP value, the packet length, precedence, or a QoS group. For us, it's a access list that we created, so we're going to choose access group with the name of RDP. Now that we have created our match condition, we can specify a policy map. Again, there's a type, and you have to make sure the type matches. And we are still doing QoS type, and we're going to call it, since it's going to be coming from VLAN 32, we just call it from VLAN 32, so we kind of know the direction as well that's going to be used for. Now for class, it's going to be the class app that we just created. And then here's a number of actions that we can do set. We can do, we'll do police in a second here, but for QoS marking, we do set, DSCP, and here's the number of options. For DSCP value, we say we're going to set it to AF21, so we'll call AF21. Okay. Now the last thing you need to do is to apply the policy map to the port profile. So both of our test server here are using port profile called VM VLAN 32, and to apply the policy map, use the command service policy and then specify the direction. You actually want to specify the type as well. It's type QoS. You can see QoS is the only typed available for port profile type v Ethernet. So type QoS and then direction. So we're going to do input. So since we're going to be marking the incoming packets from the host, and then you can see right here, it's very nice if the switch that tells you what's the name of the policy map you have configured so far, so you don't have to kind of make sure you don't have typo or anything. So you can even use tab if you want. So that is done, and that should be it for the marking part. We'll verify that in a second here, but I just want to keep going on the configuration. So the next part we're going to do is policing, which will be configured on the uplink towards the upstream switch, and we'll try to police some of the RDP traffic here. Since the RDP traffic has already been marked to AF21, we no longer need to use the access list to look for traffic. Here we can just create another class map type QoS. We'll do match any, and we'll create one called AF21. Okay, and then we do match. This time we do match DSCP instead of access group, and for DSCP it's AF21. Again, now we're going to configure the policy map type QoS, and let's call it something like to uplink. Okay, so to signify a outbound traffic from the switch or egress, and then we'll match it with AF21. And here what we want to do is police. So police, then we pick the committed information rate. Let's do something like 800 kbps. And then you have the option of conform. So if the traffic or the packet is conforming, then you want it to transmit. And if it violates, we're just going to do the 2 color, not 3 color. The 3 color you would need exceed, but for 2 color, you do violate. Instead of drop, let's start off with, we want to mark it down, like we mentioned here, from AF21 down to AF11. Again, this is just a random value that I pick, so you might choose different value in your environment. That makes sense. So set DSCP, and then table. And the way it works with the markdown is the policy map will refer back to the PRI markdown map, which I'll show you in a second here. So we want it to get marked down, so that's what the command that we do. Let's do a quick review before we do look at the table map. So show run. Okay, right here with the class map that looks for DSCP 18, which is AF22, and then the type QoS to uplink that we configured the policing on. that refers to or reference to the PRI markdown map. Okay, so the way markdown works is if you do show table map, in question mark, you can see by default there are two table maps, which is CIR markdown and PIR markdown. So for us, we're using PIR markdown map, but you can see right here by default, these are the DSCP value that will get marked down from, and this is the DSCP value that will be replacing the original value. So since the packet that we're going to be seeing is going to have the AF21, which is the decimal value of 18, by default it's going to get marked down to 22. But what we want to do is to mark it down to AF11, which is decimal value 10. So we need to modify this default entries, and the way to do that is with the command table map. And right here there's already an option for a PIR markdown map. You specify the from DSCP value. Here it doesn't give you an option to do whether it's AF or EF. We have to do it by the decimal value. So we know that the AF21 is 18, and we want to mark it down to 10. Okay, if we do show table map and PIR markdown one more time, you can see right here there's a new line or new entries for marking down 18 down to 10. Okay, the last QoS features that we want to configure is the QoS Queuing, and this is for guaranteeing bandwidth for our Nexus and VMware application data or control data. So again, everything starts off with class map as far as what type of traffic you want to match, and then when you do type, this time you want to make sure you pick queuing instead of QoS. Actually, one thing that we forgot to do is applying that policy map, uplink policy map to the port profile. So let's go back and do that. And the port profile that we will be applying that to is uplink VEM. And then we'll do policy, service policy. Again, make sure to specify the type, QoS. Direction is output, and we call it to uplink. Okay, you can even do a quick check with show policy map interface. We'll look at this in more detail in a second here, but you can see these are the interface that's currently using our policy map to uplink. Okay, here let's go back to the configuration with queuing. We were going to do class map for our queuing, and we say we want type queuing, and we want to match any. This one's going to be for the N1 KV, so let's call it N1 KV. And for the match, you can see there are two options by default, cost and protocol. We want to pick protocol, and these are some of the default control or application traffic that you can choose from. For us, we're doing N1 KV control, and then N1 KV management. If you were to use the packet VLAN, you can even specify it, although we are running layer 3 here, so it doesn't hurt to put that in. And then we create one more class map. Again, type queuing for match any, and we'll call this one VMware. And again, we match protocol, and we're just going to pick some of these that we know that we are using. So one is iSCSI, definitely management. The other one is vMotion. Okay. Next is policy map. Again, type queuing. We can just reuse the name since it's totally different type. It will take it. So to uplink, same name, with the class map type queuing, N1 KV. And here, this is where you can choose the amount of guaranteed bandwidth. You can see bandwidth is the only option. If you're familiar with the QoS, usually you will see a parity command, but it looks like the N1 KV doesn't support that. So we're stuck with using bandwidth %, and so you can even specify the exact traffic rate. It has to be a percentage of the links speed. So let's do something like 5%, and then for class type queuing, you do VMware. So you can see one thing I like about this is all these names are pre-populated, and this is the name that you configure yourself, and you can just look it up right here. bandwidth %30. Again, going back to the uplink port profile. Let's see if you can find it real quick here. Right there. Then we apply our service policy type. This time instead of QoS is queuing. You can see the only available direction is output. And again, to uplink. Okay, so now that we have all the QoS configuration in place, we can start doing some testing. So let me go back to our RDP session here. And actually, let's restart Wireshark as well. So continue without saving. And then let's go ahead and download this file one more time. And we're just going to replace. And let's pause. You can see it's happened as quickly as the first time we had no QoS because we haven't really enforced the policing. We just mark it down at this point. So if you go to the switch and then do show policy map interface PO1, you can see right here, this is our QoS service policy map to uplink that we had the policy policing configured. And you can see some of the amount of bytes that's conform, and there's some of the violated as well. And we'll see in a minute here, we'll look for the DSCP in the header. And for the queuing, you can see it started matching packets already. Here's some of the number of packets that's been matched for both Nexus 1000V and the VMware. So we know the queuing is working as well, and this is the percentage of bandwidth that we have allocated to it. Okay, and it even tells you the input-output rate for those. Okay, so we know that we have some violated traffic already. Now first, at the beginning of the video, we saw that there was by default its DSCP value is 0. So this time let's find one of these. And I already have a kind of a filter built. So let's look for a DSCP value of 18. And you can see when you search for those, there are matches everywhere with, if you look at the header, with the assure forwarding 21. Okay, so we know that these are the conform packets. At the same time, as we saw, there's some violated packets as well. So if you change our filter here to look for DSCP equal to 10, which is AF11, and we can see some matches here as well, and these are all violated traffic or packets. If you look at the header, again, AF11. Let's go back here real quick and again do a show policy map interface. Here's a port channel 1. Here's port channel 2, and here's some of the virtual Ethernet. And let's look for the one that have matches. First, it's going to be, let's look up exactly which interface that is. On the client side, so we push the file up, so it's VETH10, VETH10. You can see right here, here's a number of packet has been marked with AF21. So far it looks like everything is working as expected. The last thing we're going to do, because with the policing, what we try already is to mark it down, but this time instead of marking it down, we're going to try to drop it and see how that affects the speed of the file transfer rate. So going back to our policy map, type QoS, and it's to uplink, and our class is AF21. We're going to keep the rate pretty much the same, which is 800 kbps. And for conform, we're going to transmit. But for violate this time, instead of marking it down, we're going to drop it completely. So let's go back. Let's restart our Wireshark, clear the filter, and then let's try the file transfer one more time. Replace. You can see how things gets pretty slow here, although it's only like a 5 meg kind of file. You can see how it's making progress, but it's not as fast as it used to. And that's because we are, in the sense, rate limiting or policing the traffic down to only 800 kbps. And even the Wireshark, we'll take a look in a second here. I can see it will take a while, so let me cancel that. On Wireshark, let's stop. Okay, so let's start off with looking at the switch. Again, going back to show policy map interface PO1, and here are some of the violated number of bytes that's been violated, and the action is now dropped instead of marking it down that we had earlier. And now if you look at the capture, you can see a lot of retransmission. This is due to the packet that's being dropped by the switch. Okay, you can see before it was nice and clean, but now you can see out of order packet, dupe act, and retransmission pretty much everywhere. Obviously, if you go back to the policy map and class map and kind of crank up the allowable bandwidth right here, let's say instead of 800 kbps, let's give it maybe 3 mbps. There's the 3 band. Okay, and let's try that one more time. You can see how it goes a little bit faster, so it doesn't halt anymore. And you scroll it down, it's reporting around 240K, and that's kilobytes though. But at least the file transfer succeeded a lot faster than what we had earlier with the 800 kbps. And if you look at the capture, I mean, you still see some retransmission and dupe act, but not as much as what we had before because the switch doesn't drop the packet as much due to the higher bandwidth. Okay, although the QoS on the Nexus 1000V is not as feature-rich as compared to the bigger counterpart like a 5K or 7K, but some of the features are not available, and these are things like shaping. When we looked through the command, we didn't see any option for shaping or even priority queuing. But for what you get here, it's still much better than when you compare it to like traditional vSwitch. Okay, so that's pretty much wraps up our video on Nexus 1000V on the QoS topic. Thank you for watching LabMinutes.com, and I'll see you guys in the next video.